Hello, students of class 6. So, once again, let us see our chapter 3 playing with numbers. You have many things to do in this chapter. So, one very important thing that you should know is relation between HCF and LCM. So, what relation do the HCF and LCM share? Let's find out, but it is applicable when we find the HCF and LCM of two numbers, not more than two numbers. So this relationship of HCF and LCM with regards to the two numbers is applicable, not more than two numbers. So first let us find the HCF and LCM of these two numbers 15 and 20. So we had already done in the previous classes how to find HCF and how to find LCM. You know here 15 and 20 by common division method. That means this together we are dividing 15 and 20 by their prime factors. So their common prime factor, you know, by 2 only 20 is divisible, not 15. By 3 only 15 is divisible, not 20. So next prime number after 2 and 3 you have 5, and by 5 we can divide both of them. 5 3 times is 15 and 5 4 times is 20. Now you know that 3 and 4 do not have any common factor. So therefore we'll stop here. Hence the HCF highest common factor, we had only one here, 5. With 5 we could divide both of them. So here HCF is the 5. Now LCM, least common multiple, and again you see 3 and 4, these were not divisible, but while finding LCM we have to multiply all of them. So 5 into 3 into 4, that is what we have written here. 5 into 3 into 4, that gives us 60. 5 3 times is 15 and 15 4 times is 60. So now we got the HCF and the LCM of 15 and 20. Hence let us see the relation now. Now HCF into LCM. HCF multiplied by LCM. So HCF we had 5 and LCM we had 60. So 5 into 60 or 5 60 times is 300. Then let us find out now product of the numbers. Product of the two numbers. Those two numbers were 15 and 20, of which of these two numbers we had found out the HCF and LCM. So these two numbers 15 and 20, their product is also 300. So now from this we come to know something, that is the relation between HCF and LCM. That means HCF into LCM is always equal to the product of the two numbers. Okay, so that was the relation. Now here you come across now the relation HCF into LCM is equal to product of the numbers. Now remember, this result is true for only two numbers and not for more than two numbers. That means this relation HCF into LCM will be applicable only when there are two numbers involved. Of those two numbers you have to find the HCF LCM, and then if you multiply those two numbers HCF and LCM, and the product here you get will be always equal to the product of those two numbers. So this is the relation which we say HCF into LCM is equal to product of the two numbers. Now from this relation we deduce or we get a few relationships now here. Suppose out of these four element HCF, LCM and the two numbers. Suppose HCF is not given. So how to find out HCF? So directly using this particular relation we can find out how to we can find out the HCF. So HCF will be equal to product of the two numbers, that means first number into second number, and by or divide by the LCM, because the two numbers and LCM will be given while you will be asked to find HCF. So at that time you will be using this relationship. Then when the two numbers are given and you are asked to find the LCM, two numbers are given and HCF is also given and you are asked to find LCM, then you may write LCM is equal to product of the two numbers, that means one number into the other given number, divide by the HCF. And the third thing is other number. Now, out of two numbers, suppose one number is given, HCF and LCM both are given, but the other number is not given. Out of two numbers, one is given and one is not given. Then to find that missing number or the other number, it will be other number equal to HCF into LCM, that means product of HCF and LCM divided by the given number. So this is how we can find out HCF or LCM or the other number whenever out of four elements three are given, because there are four elements involved. You can see it here. One is HCF, other is LCM, then there are two numbers, one number into the other number. So two numbers here and HCF, LCM all together make four elements. Out of four, if three are given and one is not given, then that whichever is not given, we can find it out using these three relationships. Okay, so now we will move to the other thing, that is exercise. Now you see in exercise 3.2, question number 6, you have given two numbers 15 and 25. Find their HCF and LCM and verify that HCF into LCM is equal to 15 into 25. That is the thing that we did just now, relation between HCF and LCM, that means product of HCF and LCM is equal to product of the two numbers. Okay, so as I had given in the example, it is a similar case. So you will first find out LCM as well as HCF of 15 and 25. So by common division method is the most convenient one. You may apply that. So 15 and 25 divided by their common factor, that is 5. So 5 3 times 15 and 5 times 25. So their HCF we got 5, because 3 and 5 don't have any common factor other than 1. 1 is now meaningless, 1 is a factor of every number. So now these 3 and 5, both of them are prime numbers. So we will stop here in our division. So from here only we got our HCF. The HCF is 5 and the LCM will be the product of all three of them. That means 5 into 3 into 5, which we have here. 5 times is 25 and 25 3 times is 75. So we got the HCF 5 and LCM 75. Now what we have to do, we have to see here, we are asked to show that or verify that HCF into LCM will be equal to product of the two numbers. So we will now here multiply HCF into LCM. So 5 into 75, we get 375. On the other side, you multiply the the product of the two numbers. So 15 into 25. So 15 into 25 also gives us 375. So we saw that HCF into LCM was equal to product of the two numbers. So hence HCF into LCM equal to 15 into 25, 15 into 25. Therefore, it is verified. Now, you will be doing question number 7, which is home task for you. Okay.